So today we're going to learn how to write and solve inequalities from real world situations. So we've already talked about how to write inequalities like these first four examples that are on your notes right here, but today we're going to focus more on writing one-step and two-step inequalities. On this first problem, I took a picture of this chart from our 9A notes, and I just added it here just so we could use some of these word phrases to help us out with our inequalities. Keep in mind for a test you won't get this chart, so we'll talk about different strategies that we can use to figure out what our inequality is going to be, but I have it here just to reference back to as we answer these questions. So let me remind you, when we did our 9A notes, like I said, we did a few of these problems together, but let's take a look at these first four questions. And when you're doing these questions, we always want to make sure that we're naming a variable. So in this first one, the minimum voting age is X, or is 18. So I'm going to name a variable here, and we're always going to name a variable. So I'm going to always name it X. You can name it any letter you want to. And I'm going to say it's X. This stands for the voting age. And then notice in this question it says the minimum voting age is 18 years old. So the age that someone has to be, and when I typically write these inequalities, because minimum is not a key phrase right here, so it doesn't really help us. So if I know that the minimum age is 18, what we typically do is we just say, okay, if you want to vote, can you be less than 18? Can you be equal to 18? And can you be greater than 18 years old? If the minimum voting age is 18, it means somebody could be older than 18 and vote, so the age could be greater than 18. They could also be equal to 18 years old, but they cannot be younger than 18. So that age, the X that we're talking about here, cannot be less than 18, so it's got to be greater than or equal to. Okay, let's try number 2. Our delivery time is guaranteed to be less than 30 minutes. So it must be less than 30 minutes. So name a variable. In this case, I'm going to use X again, and it's the delivery time. And it says specifically that this delivery time is less than 30 minutes. So this X and that one, if it says less than, you can just go ahead and use your less than symbol. So it says less than, so I know that the delivery time is going to be less than 30 minutes. Okay, if they say it's going to be less than 30 minutes, it can't be more than 30 minutes. It also won't be equal to 30 minutes. Otherwise, they would say less than or equal to 30 minutes. So it must be less than 30. Okay, let's try another one. A score of at least 92% on the test is considered an A. So let's name a variable. And I'll say X, and this is going to be the score on the test. Okay, so X is your score. Okay, and so let's put we're always going to put our variable first. And then let's say you need at least, so it says at least 92. So if your score on the test is at least 92, you could get an A. So if you score greater than 92%, then you would also get an A. So it could be greater than 92. If you want to get an A, you could score greater than 92. You could also score equal to 92. You just can't score less than 92% in order to receive an A. So this one I need X is greater than or equal to 92. And if you look on your chart that we have from our 9A notes, at least is right here, and that's greater than or equal to. So that chart also has at least written right there. All right, let's try number 4. So the bus seats at most 60 people. So X stands for the people on the bus. Okay, and it's at most 60 people. So let's highlight at most. That's our key phrase there. We're going to start with X. And if they can seat at most 60 people, so 60 people is the most people that could fit on the bus. Could less than 60 people fit on the bus? Yeah. Could equal to 60 people fit on the bus? Yes. Could more than 60 people fit on the bus? Well, if the bus seats at most 60 people, then you cannot fit more than 60 people on the bus. So I just need X is less than or equal to 60. Okay, and this chart right here also has at most being less than or equal to, so we know we're good there. Okay, so always name a variable and then put your inequality here. And these ones, you don't have to solve anything because there is nothing to solve. But let's scroll to our second page. And on our second page here, this is where we actually have our 1 and 2 step inequalities, where you do the same thing. So you still define a variable, but then you have to write your equality and you have to actually solve it in these ones. Okay, so your first step is always going to be to name the variable. Your second step is going to be to write the inequality. Okay, and then your final step is going to be to solve the inequality. And we always have to make sure, let's go and highlight this, you always have to make sure that you're labeling your answers. So we name a variable, write an inequality, and then solve that inequality and make sure we label our answer. Okay, so let's take a look at number 1. And let's highlight our key phrases as I read this to you. So Sharon has D dollars in her savings account. She wants to buy a new sweater that costs $65, and she still wants to have at least $200 in her savings account left. So how much money does Sharon need to have in her savings account to do this? Okay, so let's always name a variable. So I'm going to say X is my variable, and this is money in savings account. Okay, and just to clarify, this is the money in her savings account before she buys the $65 sweater. Okay, so she has D dollars, and actually I'm going to change this because it tells us to use D. So let's use D dollars, and that's the money in her savings account. And then let's write our inequality. So in her savings account, she starts with D dollars, and then she buys a sweater that cost $65. So if she started with D dollars, but then she buys a sweater, her bank account is going down by $65 because she's buying a new sweater. So when you buy something, you spend money or you lose money or your bank account goes down. So I know I need to subtract $65. Okay, and she wants this amount, because this is the amount in her savings account right now after she buys the sweater. She wants that to be at least $200. So if it needs to be at least $200, could it be greater than $200? Yeah. Could it be equal to $200? Yep. Could it be less than $200? Well, if the least amount in that bank account can be $200, it cannot be smaller than $200. So we're going to say greater than or equal to $200. And again, that chart that we had from our 9A notes, at least right here, is always going to be greater than or equal to. So anytime you see at least, you're always going to put greater than or equal to. All right, and then from here, we're just going to solve it. So let's solve this inequality. I have D minus 65 is greater than or equal to 200. We draw our line down. The opposite of subtracting 65 is to add 65. So I'm going to add 65 on both sides. Okay, and I have D is greater than or equal to $265. So that means that before she buys the sweater, she needs to have at least $265 in her bank account. She can have more than $265 and she can have equal to $265, but she cannot have less than $265. So D is greater than or equal to $265. Final answer. And these will always be 3-point questions. So it's 1 point for naming your variable, another point for your inequality, and then a final point for having a final answer and labeling it. Okay, let's try another one. So number 2, the student council is hosting a fundraiser. They have collected $480 in donations, and then they also make $6 for each tub of cookie dough they sell. How many tubs of cookie dough will they need to sell in order to make a minimum of $600? All right, so let's start in our question. The question says how many tubs of cookie dough. So let's go ahead and label this T, and it stands for tubs of cookie dough. Okay, so this is T, stands for tubs of cookie dough. Okay, and then we write these very similar to how we write equations. So we typically start at the end with equations. Usually we put an equal sign. We're not going to put that here because we don't have equations anymore. So let's take our $600 Anytime they tell you the final cost or the final bill, or here they tell you how much they want to make on their fundraiser, that always goes at the end. And then let's figure out what goes in front. So we're going to leave a space in the middle. This is where our inequality symbol, like greater than, less than, that's where that's going to go. Let's figure out what goes in front of my inequality. So let's start by finding out which number has to go next to T. So if T stands for tubs of cookie dough, look in your problem, and is it they make $4.80 for each tub of cookie dough, or they make $6 for each tub of cookie dough? We already used the 600, so we can't use that again. It says they make $6 for each tub of cookie dough, so I'm going to put 6T, okay? And then they also have already made $480 in donation, and that's just a fixed amount. So that's just a set amount they have in donations. Okay, this total amount here is how much they're making on their fundraiser, and they want this total amount to be a minimum of $600. So if the minimum is $600, they could make equal to $600, and they could make more than $600. That'd be great. It's a fundraiser. You can make more than your goal, but they don't want to make less than $600. So they don't want anything smaller than $600. So our inequality here is 6T, because it's $6 for each tub of cookie dough, plus the $480 in donation, has to be bigger than or equal to their goal, which is $600. Okay, once we have that, let's go ahead and solve it. So let's subtract 480. And this solving is just like solving your normal two-step equations, but it's just an inequality instead. So instead of saying equals in the middle, we're going to keep our greater than or equal to sign. Let's do some borrowing. 9, whoops. So 0 minus 0 is 0, 10 minus 8 is 2, 5 minus 4 is 1, so I have 120. Divide both sides by 6. Okay, so I have T is greater than or equal. I know 6 goes into 12 2 times, so 20, and then remember T stands for tubs, so they would need to sell 20 tubs of cookie dough. Final answer. And again, these are 3-pointers. So 1 point for saying what your variable stands for, 1 point for your inequality, and then 1 point for your final answer. So they, in order to reach their goal, which is a minimum of $600, in order to reach that, they could sell 20 tubs, or they could sell anything more than 20 tubs, but they cannot sell anything less than 20 tubs of cookie dough. All right, we got 2 more. Let's try number 3, and I'm going to have you guys try this on your own. So I'll read it for you. Let's highlight our key phrases here. John needs to call a plumber. The plumber charges a flat fee of $50 plus an additional $12 per hour. John forgot to check the time when the plumber arrived, but he knows he spent less than $110 for the service. So how long was the plumber at John's house? So let's first, on your own, go ahead and see if you can name a variable and tell me what does it stand for. Okay, since the question says how long, I know I'm talking about time, and in this case, in terms of time, we're talking about hours. So let's say H stands for number of hours, and you can be specific and say number of hours plumber is at your house. I'm just going to say H is just our number of hours. Now let's start writing our inequality. So here's some hints, and I'm going to have you write it on your own. Your biggest number is always going to go back at the end, and then try to figure out which number, if H is hours, figure out which of these numbers is going to go next to H. And then there's a plus to tell you that you're going to be adding as well in this inequality. And then think if it says less than, which symbol are you going to use? So go ahead and write your inequality. Okay, so my 110 is going to go at the end because I know that he spent less than $110, and that would be his final price. And then let's figure out what goes in front of our inequality. I'm always going to leave a space here and then find my symbol last. So I know, let's figure out which number goes next to H. It's either $50 per hour or $12 per hour. And if you notice, it says 12 per hour. So here's my $12 per hour. And then it also says he has to add on an additional fee of $50. So there's the plus 50. And then it specifically says that the amount he spent was less than. So all this amount right here was less than $110. Okay, once you have that, let's go ahead and solve it. So we have 12H, and if you didn't have that, go ahead and erase it and fix it, and let's do our solving now. And I always rewrite it just so when I subtract 50 on both sides, I can cross it off without it messing up my final inequality right here. But go ahead and solve this inequality and then label your final answer. Go ahead. Okay, so as we're solving this, we're going to subtract 50 on both sides because that gets rid of the adding 50. So let's subtract 50 on both sides. We have 12h is less than 60. And then let's divide both sides by 12. Okay, and so I have h is less than, and then I know 60 divided by 12 is 5, or I know if you want to think 12 times 5 gives you 60. That's another way to think about it. So I know h is less than 5 hours, which means the plumber had to have been at his house for less than 5 hours because he knows he paid less than 110. So the plumber had to be at his house for less than 5 hours. So again, here are your 3 points. H is hours. There's your inequality. Here's your final answer. All right, last one. So Justina and her friends, let's go ahead and highlight our key phrases. Justina and her friends are going bowling for her birthday. The bowling alley charges a one-time lane fee of $25 plus $10 per hour. If Justine wants to spend more than $65 on her party, then how many hours do Justine and her friends need to bowl? So go ahead and name a variable for this one. Okay, if you look at your question, it says how many hours. So let's say H stands for the number of hours. So that's how many hours her and her friends are going to bowl for. Okay, and there's your first point. Now let's try to name your inequality. So read the problem again and see if you can figure out what would your inequality be for this one. All right, so if you know she wants to spend more than $65, let's put our 65 at the end because that's our final price that she wants to end up spending. She wants to spend more than that, but that's our final price. As always, try to figure out what number is going to go next to H. H is hours. It's either 25 per hour or 10 per hour. Notice it says 10 per hour, so I'm going to put 10H. And then you also have to pay this extra lane fee of $25, so plus 25, okay? And it says she wants to spend more than $65. So if it's more than $65, could it be less than 65? No. Could it be equal to 65? Well, no, because she says specifically more than $65. So we need greater than for this inequality. Okay, so again, if you had that inequality incorrect, let's go ahead and fix it because when you solve it, you're going to need to solve this inequality in case yours was wrong. Okay, so it's $10 per hour, which is our 10H, plus the $25 lane fee. She wants this price, this amount that she's about to spend on her party, she wants that to be bigger, so greater than $65, okay? If that was wrong, go ahead and fix it on your notes, and now let's go ahead and solve it. Okay, when you go to solve this, we draw our line straight down. We're going to subtract 25 on each side, okay? Bring down your 10H. We have greater than in the middle. I know 65 minus 25 gives me 40. I'm going to divide this by 10, divide that by 10. So I know H is greater than, and then I know 40 divided by 10 is 4. And then we like to use variables that have to do with our label. That way it helps us decide that this stands for 4 hours. So if she wants to spend more than $65 on her party, then she needs to bowl, or her and her friends need to bowl for more than 4 hours. So H is greater than 4 hours. There's our final answer with a label. All right, so let's keep these notes handy because they're going to be very helpful when it comes to writing your own inequalities on your practice. As always, you're going to name a variable every time. Look at your last sentence. So if you're not sure how to name your variable, look at your last sentence, and that will help you name your variable. So if it says how many hours, use H for hours. How many tubs of cookie dough, use T for tubs. So look at your last sentence, and that's a good place to start to figure out what your variable is going to be. We're going to write our inequality, and then you're going to solve the inequality that you have. And keep in mind, if it doesn't come out to a nice number, we want to check back and make sure we didn't make a mistake either in our math or in our inequality to begin with. Okay, so keep these out so you can review them and use them to help you out with your homework if you didn't have a chance to get all of these written down. Here's all of it if you want to pause the video and just catch up with whatever you didn't have a chance to write. Biggest thing, please make sure you have variable, inequality, final answer with a label. Make sure you label your final answers. All right, As always, let me know if you have any questions, and great job.